Hey everybody, so glad we're coming to an end here, and we are starting our last small little unit on probability and statistics. I know we just finished a stats unit, so really I should just focus on the whole probability part. So we're just gonna touch the surface on this just so you have an idea of probability and some combinations and permutations and factorial and some of our ways that we can count the number of outcomes that certain situations have. So we've got just a few lessons, real short unit. So let's finish strong, everybody. You're doing such a great job. I'm so proud of you. So here we go. So the first thing that we are doing is something called the fundamental counting principle. Okay, so what that does is what it's talking about, if a decision, and we're calling it decision M, it can be made in a certain number of ways, and decision N can be made in a certain number of ways. So what that means that a lot of times we call this a slot method. So let me just go into the first example because I think it will help, and then we'll go back to that definition. It says the ice cream shop offers a choice of 3 cone sizes, 15 flavors, and 8 toppings. So what we've got here, guys, is we have 3 different categories. We have a category for the cone sizes, we have a category for our flavor choices, and we have a category for our 8 toppings. Okay, so what we do is we kind of separate this problem into how many different categories we have. Or topics we have. So what we would do is we would create a slot for our cone, because that was one of our categories. We would create another slot. This is called your slot method for all of your flavors. And then we would create a third slot for our third category, and that was our toppings. So then we look at how many choices do we have within each category? Well, it told me that I have 3 cone choices. So I would put a 3 in my slot for cone. I had 15 flavors to choose from for ice cream. And then we had 8 toppings. So if we go back up to what this is, it says decision M. So in our case, it's more like a category. That's the way I described it. So our decision M, or cone in our first example, can be made, and we're going to call it X ways. And decision N, so we had a different topic, a different category. Our next category was flavors. So I created another slot for flavors. It can be decided on in Y ways. So for us, X would be 3 and Y would be 15. So it's your number of choices per slot. Then the 2 decisions can be made. And what you do with a slot method is you multiply all of those numbers. So for us, we're going to multiply 3 times 15 times 8. So we have 45 times 8, which would be 360. So if this were your ice cream shop, we could advertise and say, we have 360 different ice cream cones that we can create for you. Okay, if you chose 1 cone, 1 flavor, 1 topping, there would be 360 different ice cream cones that you could create. Okay, so next example, let's figure out our slots. It says a Virginia license plate consists of 3 letters followed by 4 digits. So when we think about our category, is we have a category for our letter. We have another category for our letter, and a third category for a letter. There are 3 letters on my license plate, so there would be 3 slots for letters. And then it says it's followed by 4 digits. Well, a digit is a single number, so therefore I have to create 4 slots. Each of these slots would represent a digit. So I have in total 7 slots, because there are 3 of them that are letters and 4 of them that are digits. Now we're going to get into this a little bit more in depth later, but there's going to be times where it's okay to repeat letters or numbers, and there's sometimes that there's not okay to repeat letters or numbers. Now on a license plate, you absolutely can repeat letters and you can repeat numbers. So how many letters in the US alphabet are there? There are 26. So that means each of these categories for letters has 26 different options. Okay, because we can repeat. Now digits, your first reaction is probably to tell me that there are 9 choices, but let's count. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Okay, those are the digits that we have available. And because 0 is a digit, there are actually 10 choices per digit that I could create. So all of this, because this is a slot method, we would go ahead and multiply all of these together. Now, chances are your calculator would not be able to do this. So what I would suggest to you is go to your calculator, and I would enter in 26 times 26 times 26. And I would take that big number, 17,576. And then I see that I have multiplied it by 4 tens, which means I'm going to add 4 zeros on the end and then add my commas. Lots of different choices for license plates. So if you've ever wondered, are they ever going to run out? There's an example of no. And then you've got the fact that not all license plate even need 7 numbers or digits or a combination. Okay, so then next one, we're just going to set it up because sometimes true false questions can have a tricky idea, but the science test has a section with 12 true or false questions. So some of you have a hard time deciphering how many categories. So remember, each question is its own individual assignment. So in this case, there would be 12 categories, with each question being its own category. And how many choices do I have per question? Well, I only have true or I only have false. So there are only 2 options per question that I could choose, true or false. So this would be 2 to the 12th power. Okay, I'm okay with you writing it in exponential. All right, so that's the slot method. You creating your categories, putting a slot for each category, and then telling me how many choices you have per category. So then there's something called a factorial. This is where math gets super excited, okay? Factorial, you're gonna see some number, then you're gonna see an exclamation point next to it. It's excited math. And usually when I'm in the classroom with you, I would yell, I would dance, I would say 9 if we were doing it, and you'd laugh at me because it's a totally lame math joke, but you know, it is what it is. So this is excited math, okay? What factorial is, it's the multiplication of all numbers from the number that you started with down through 1, okay? Or technically it's down through 0, but I'll explain what that means here in a moment. So let me show you what this would actually mean, and then I'll show you where it is in your calculator. So what factorial is in this one, we've got 9. It's excited 9. This would mean that we would start with 9 and we would multiply by all of the numbers below it, okay, through 1. Now, some places will say through 0, but I think it's been easier to just tell you guys go through 1. So we would do all of this multiplication, okay? Now this would be a lot for us to multiply, so let's go to our calculators. What I want you to hit is I want you to enter in 9, and then I want you to hit your math button. And we're going to be focused right here on our probability menu because we are in our probability unit. So let's scroll over into our probability. And these are going to be our main 3. This I'll explain, but this is permutation. this is combination, and there it is. There's your excited, your exclamation point, your factorial. So your calculator actually does that work for you. This is going to come out to be 362,880. Go back to notes. And there's your factorial. So it's in your, you're going to hit your math button. You're going to scroll over to your probability menu. Depending on your calculator, it'll say PRB or maybe PROB, but your probability menu. And then this is choice number 4. And there is a definition on factorial that I do want to give you. By definition, 0 factorial is always going to be equal 1. That's just going to be a definition that you need to know. And if there ever comes a time in which you have a big factorial problem, what you need to remember is what factorial means. Factorial means the number that you're starting with times all the numbers below it through 1. So I have 17 factorial written here. A little bit of a lag. And then I'm going to divide it by 11 factorial. Well, I'm going to do this on purpose. I'm going to start with 11 down here. 11 factorials, 11 times 10 times 9, all the way down through 8. And I hope that you remember that if you're if you're dividing and you see that there's a whole bunch of stuff that's being multiplied together, and some of it's in the numerator and some's in the denominator, I hope that you do remember that when you are dividing anything that is in the numerator and the denominator, as long as they're multiplied, they do cancel each other out. So we would be able to do this work by just multiplying 17 times 16 times 15 times 14 times 13 times 12. Now you're going to see some problems on your homework tomorrow that require you to do some exponent properties. Okay, so if I gave you something like n factorial over n minus 1 factorial, I need you to remember what factorial is. You start where you are, and then you multiply by one term less than that. So by definition, n factorial would be n times n minus 1, subtract whatever n is, times, subtract 1 again, so that would be n minus 2, times, subtract 1 again, n minus 3, and so on and so forth. So I'll put my dots down there. That pattern would continue. Well, n minus 1 factorial starts at n minus 1, subtract 1, so n minus 1 minus 1 gives us my n minus 2, n minus 3, n minus 4, and so on and so forth. And just like I told you before, anytime that there's something in the numerator and the denominator, it's going to cancel each other out as long as they're being multiplied. So this entire thing would simplify to just simply be n. Okay, so make sure you are subtracting 1, not adding 1. Adding 1 is a common mistake. Make sure you're subtracting. All right, so then we've got situations, something called a permutation versus a combination. And I need you to know that with a permutation, biggest thing, and I'm going to emphasize this a bunch, is that order matters. Example, if you're running a race in track, okay? If you place first place versus second versus third, that order matters. It definitely matters whether you place first, second, or third. Example 2, I'm creating a group of 3 students and I call Mike, Sam, and Alex. Okay, I'm just simply creating a group. You guys are working together. That is not different on if I said Mike, Alex, Sam, or Sam, Alex, Mike. Okay, it's still the same 3 people together. So there are situations where order matters, situation where order does not matter. Okay, so an arrangement or a lineup of objects in which, and I kind of put that here already, but I'm going to write it again, order matters, is called a permutation. So if you remember seeing that, that is in your math menu. Again, scroll over to your probability menu. I'll let my iPad catch up here for just a minute. Permutations. So anytime that you are in a position, so president, vice president, secretary, anytime that you are in a photograph, imagine taking a picture and your best friend is on your left, next picture your best friend's on your right. That is a different picture. That order matters. So permutations, photographs, positions, those are your main ones. Anytime that your order specifically matters. Actually, your locker combination or your gym combination is actually a permutation because it absolutely matters the order in which you put in your numbers. Okay, so this is going to be your math, your probability, and it is option number 2. Okay, so we're going to do option number 2. So what I want you guys to see is on your homework, you're going to see it where it's going to be a probability, and then you're going to see a n comma r. You're going to see a number comma another number. So what I want you to identify is in your calculator, this n is written first. In your homework, you're going to see a lot of times where that n is first in that set of parentheses. And what n represents is it is your total number of objects available. So if you're picking a card, one card, you've got 26 cards in a deck. So you would choose, n would be 26. Okay, that ice cream cone example, we had 3 ice cream cones. So I would have an n value of 3. That's how many cones I had available to me. So then we've got this r. R is going to be written second. R is going to be after the P. And R is your number of objects that you are choosing. Okay, what I have highlighted there on notes, it's fancy. So it's R is how many you're choosing. So for our ice cream cone, we would do a permutation, 3 choosing, and you would have a 1 because you were only choosing 1 ice cream cone. Okay, so what I want you guys to see, depending on your calculator, some of you, if you have one of the older calculators, you are physically going to have to enter, let me just do an example here. If I was saying, hey, of 5 objects, you're choosing 2, how many ways can this happen? Some of you are going to have to hit 5. Then you're going to have to hit your math button, scroll over to your probability, choose option number 2, which then it will pop up this NPR, and then you're physically going to have to write the number 2. Okay, so you're going to put it in there. If you have one of the newer calculators, it's a fill in the blank. So we would go NPR, and you'll see that it's a big fill in the blank. So we would have 5 objects to choose from. We're choosing 2 of them, and it will tell me that there are 20 different ways that that can happen. Okay, so depending on which calculator mode you have, you might have to enter that number, then do your math, then do your R number. Okay, but we'll work that. If you're having a hard time, just let me know. And I just made up that example just so you guys could see. Okay, so how many ways can we arrange the letters in the word dinosaur? So it's an arrangement of letters, so it doesn't have to be a word. So I would say that the order matters, okay, because that would change my letters. So how many letters are in the word dinosaur? There are 8. And I'm going to use all of those letters. So I'm going to choose all 8. So if we go in there, again, some of you are going to have to hit 8 and then math, and then scroll over to your probability, and then choose your NPR. Now notice mine kind of filled in the blank there for us already. And then we're going to fill in that other blank, which is 8. So there are 40,320 different arrangements of the letters in dinosaur. Pretty crazy. Okay, so we have 7 students completing in a geography B. How many ways can they finish in first, second, and third? So this would be a probability or a permutation, excuse me. There are 7 students and I am choosing 3 of them. I'm choosing 3 because I'm looking at the positions of first, second, third. Okay? And you would again use your calculator for that. So moving forward, I'm going to go in permutations with repetition. So I'm going to skip a few examples. If there are times that you are having repeated letters, such as the O in automobile, what you're going to do is you're going to have to use factorial for this one. So you're going to have your number of letters on the top. So in this case, there are 4, 8, 10 letters in automobile. So I would have 10 factorial in the top. And in the bottom, you're going to list out what letters repeat and how many times they repeat. Because what happens is if I just switch those O's, it's not going to give me a different letter arrangement. So we actually have to divide out or remove out the number of times that letters repeat. So looking at the word automobile, we only have no other letters repeat. So I would put a 2 down there because that's the number of times that O's repeat, and I would divide out by 2 factorial. Okay, if we go into this next one, we have a 9 letter in the word disappear. So I would have 9 letters. And what I'm seeing is that I have 2 P's. So I'd put 2 factorial down there. I have 2 A's, so I'm going to put another 2 factorial down there. And I don't think any other letters repeat. Now I want you to know 2 factorial times 2 factorial, because these are multiplied, is not 4 factorial. 2 times 1 is 2. 2 times 1 is 2. 2 times 2 is a total of 4. Where 4 factorial, remember, would be 4 times 3 times 2 times 1, which is 24. So do not multiply them. You do need to use parentheses in your calculator, otherwise the order of operations will not work correctly. But that would be all calculator work from there. So then we've got combinations. So combination is, oh my goodness, stop, Diego. So sorry. Combination is when order does not matter. So this was that group example that I gave you, that Sam, Alex, and I forgot the last name that I used. It doesn't matter. I'm putting you in a group. Okay. Cards. If you're ever doing playing cards, cards are always combinations. Okay. Because what's the first thing you do if you do play cards? You rearrange them in your hand, but it's still the same cards that are in your hand. So, you're going to see this with a C in front. It's still N, R. In your calculator, it's going to be NCR, C standing for combination. And it's a group in which order does not matter. So doesn't matter. Okay, so this, again, it's found in your math. Scroll over to probability. And this is option number 3. Option number 3. N is still your total number of objects that you have to choose from, and R is the total number of objects that you're choosing. So how many people are going in your group? Okay, so looking at this first example, Natalie has 16 close friends. How many ways can she choose 5 to be bridesmaids in her wedding? So the order doesn't matter. Some of you will disagree with that, but I'm going to tell you for this situation, the order doesn't matter. They're all bridesmaids. Stop. So sorry. Bridesmaids, we're going to say they don't matter. So we would have a combination, 16 people in her group, and we are choosing 5 of them. So let's look at what this is. So I would have 16. I'm going to go to my math menu. I'm going to scroll over to probability, choice number 3, and I'm choosing 5 bridesmaids. Now you're going to notice that these numbers are a lot smaller, and you're not crazy. Because of the fact that order doesn't matter, there's a lot less choices to be made, because Sam, Alex, Matt is the same thing as Matt, Alex, Sam. Same thing. where in a permutation, those would be 2 different scenarios. So combinations are going to yield smaller numbers. Okay, number 13, we've got 24 students in Kyle's kindergarten class. Choose 8 to attend his birthday party. So this would be a combination 24. You are choosing 8. Again, pull out your calculator. Okay. So good luck on today's homework. I think that pretty much covers it. I'm just trying to read the last couple, make sure there's nothing in there that I need to go over with you, which I don't think that there is. Actually, 14, let's look. There are 18 kittens. How many ways can she choose 2? So I guess this wasn't 18 kittens. You're choosing 2. So a lot of calculator work today. Sometimes it's slot, sometimes it's permutation, sometimes it's combination, sometimes it's factorial. We're going to spend today on it and tomorrow. So if this feels like a lot, I'm sorry, it a little bit is, but we've got 2 days to go over it. Please don't ever hesitate to ask questions, okay? So thanks again. So sorry my dumb dog barked in the middle of this a couple times. I apologize for that. I should have put him in his cage, but quiet spaces in my house is a hard thing to find right now. So great job. Let's finish strong, guys. Great, 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 great work.